We're going to leave the last two, 11 and 12, for Friday. And Natalie Ellison, if you don't get it together, you're about to be a YouTube star. I do not have time for you. Okay. Let's see. Table 3 can add a point. Table 4 can add a point. Table 1, Table 2. Not Table 2. Table 1, Table 3, Table 4, Table 5. Everyone but Table 2. No offense, Table 2. Everyone but Table 2. You knew what I meant. Okay. We are going to save the two wordy ones for Friday. We're not going to do any math workshops tomorrow. Why is that? We have a quiz tomorrow. Table 2, you can now have a point. You can at least be on the board. Say it again, man. You didn't get one? I put it on guy beside your desk whose name has left me now. It's going to come. It's not Reagan because Reagan's that one. It's not going to come. He's going to tell me. Did you lose my point sheet? You. I put it on your desk. 30 seconds of my life. I'll never do that again. Okay. I'm needing a volunteer for number 9. Yes, ma'am.
4x squared minus 11x plus 5.
Okay, as discussed before, Miss Compton has to distribute her negatives or else her life goes all bad. So it would have been 3x squared minus 7x plus 5 plus x squared minus 4x. Let's see if Natalie's right. 3 and 1 really is 4. Negative 7, negative 4 really is negative 11. She is correct. She can give her group a point. Okay, would someone different like to volunteer for number 10? Yes, table 3.
I got 3c squared.
3c squared minus 2c, and then what? I'll pick that up later. Plus 5. 3c squared, that seems right. 2 and 1 is 3. 7, negative 9 is negative 2. 4 and 1 is 5. That seems perfect. Good job, Paige. Okay, are there any questions on these two math workshop problems? I have so many things planned. I would love to get to 2 ACT problems. I would love to make that happen. But if for some godforsaken reason that can't happen, we will somehow do like 4 of those tomorrow when we do our quiz. When everyone gets some of their quiz, we'll work on that. Now, I don't know. I'm recording on YouTube, so I'm going to say this as nicely as possible. I don't know who they think I am to think that I can teach and give you a quiz on the same day. I don't know about y'all, but I take my sweet time on quizzes, so you are allowed to take your sweet time on the quiz tomorrow. Now, if everyone gets done, can we do some ACT prep to make sure you're good to go and keep you motivated in life? Yes, we could. But I'm not rushing Seth. I'm not rushing Seth through this quiz. If he takes the whole class period, he takes the whole class period. It is what it is. We'll have to make up our time somewhere else. Okay, speaking of making up time, go ahead and get out your packet. We had just started. No, I'm not checking your homework right this second. I swear I will check it later. Yesterday we were discussing how to go from algebraic to verbal or verbal to algebraic. I think we all were pretty good if there's a sentence on how to write the algebra. I feel like 1 through 4 in our notes you seem pretty happy with. The ones we're least happy with are 5 through 8. But again, what I forgot to say, because again, you have me first period, bless your heart. What I forgot to say is you don't have to sound fancy like me. I sound super fancy. For instance, on number 5, I say 9 less than a number squared is the same as 72. If Natalie wrote on her paper a number squared minus 9 is equal to 72. I cannot get mad at her for that. There is nothing wrong with that different sentence.
You accept that?
I completely accept that.
Good.
Now again, Miss Compton tends to be, I'm going to call it fancy. I tend to be fancy, and instead of putting minus, I put phrases like less than. Or instead of addition, I put more than. But do you have to be fancy? Absolutely not. As long as you take the equation and write it in words, you're good to go. Okay, I swear I will check that homework, but not this exact second because, again, bit off more than I could chew today. Okay, let's go on to page 8. It's the next page on the back. There are some steps to solving an equation, which I'm sure you already know. It's what we've been doing already about getting rid of the fractions, combining like terms. I think you already know these steps, but just as a refresher, there are 5 steps if you want to consider those. We are going to, since we're in a hurry, there are some of these problems that we're going to let go because they're either too easy or too hard or whatever. So I'm going to be like Goldilocks today. We are going to let some of them go. Okay, on this first problem, any thoughts on what I need to do to solve for y?
Make it positive.
Okay, I heard Addison first, so table 1 came at the point. Add 8 to both sides. So I'll have negative 6y equals 24. So now what do I do?
Divide.
Okay, I'm going to divide by negative 6, and I heard quite a few groups of that one, so I'm going to let it go. And I end up getting y equals... Okay, I heard 3 and 2, so 3 and 2 can get a point. I'm sure there are more, but that's who I heard. Okay, now if, for instance, Natalie has I don't know why Natalie should date you. Well, I do know because I know her name. If you had a bunch of free time, which we do not today, but tomorrow I'm telling you, whole class period, 15 problems if you need it. So if Seth wants to make sure he is 100% correct from here, what could he do? Plug it back in. So every group can have a point for that. I saw some mouths moving everywhere. So Seth wants to make sure he's completely right. He plugs back in that negative 4 to make sure it all works out. And it would end up being positive 24 minus 8, which actually is positive 16. Okay, let's go to number 2.
Cancel the p's out first.
That sounds like a great idea. So what do you want me to do specifically?
Divide.
Minus 5p
Okay, table 2, you can have your point. I'm going to subtract 5p from both sides.
and add 1p to both sides.
He's going to do 2 steps at once. I tend to be a 1-step person. If you're a 2-step person at once, that's fine as long as you keep up with your work. Okay, so I subtracted 5p from both sides of my equation. I brought down my 12. I brought down my negative 20, but 9 minus 5 is 4. Great.
Add 20 to 20.
Okay, if I add 20 to both sides, I've got 32 equals 4p. And you and I know that I'm going to divide by 4, and I end up getting p equals 8. And you have to admit you heard her first, right?
Yeah.
Of course you say that, Gracie Lou.
I mean, she's
Me?
allowed this.
Oh, yeah.
Everybody can have a point. I'm generous with my points today. Okay, does anyone have a question on 1 or 2? 1 and 2 were nice compared to 3, 4, 5, and 6 because there were no decimals, there were no fractions, everything was straightforward, easy peasy. You should already be able to solve that kind of an equation. Someone in 0 period asked me for specifics about the quiz tomorrow, and when we finish all the things, I will go over the specifics. So if you need to study this and this and this. Okay, on number 3, I'm going to have to distribute that 1/2 or that 0.5. So I get 0.5c. I need to know 2.8 times 0.5. Who said it? It was you. Table 5 gets a point. Okay, I can't do anything yet with that right-hand side. I'm just writing it down again.
You're going to combine 0.5c with negative c.
You can have a point for that. So what I was going to ask is, what should we do before we start moving things around the equation? Shouldn't we combine like terms? And she suggested that. So 0.5 and negative 1 makes negative 0.5. So I have negative 0.5c plus 1.4 equals 0.6c plus 0.3.
Now you're going to do 0.6c minus negative 0.5c.
I could do that. I actually think I'm going to do it the way Arturo was doing it earlier. I think I'm going to move the 0.5c over. But that's just me trying to keep everybody positive. Can you absolutely get the correct answer the other way? Of course. So I have 1.4 equals, I'm adding 0.6 and 0.5, I get 1.1c plus 0.3.
Now you're gonna do minus 0.3 and 1.4.
I subtract 0.3 from both sides. I have something equals 1.1c. What is that something? Table 2 again. So 1.1 equals 1.1c. So what does c equal?
1. 0.
0 or 1? So in your calculator, type 1.1 divided by 1.1, and let's see. Okay, we really do get 1. I don't know. There were a lot of zeros going on, too. Okay, are there any questions on number 3? Okay, we will go to number 4, but you can go ahead and cross out number 5. On number 5, you distribute twice, and I'm sure you can handle it. There are no fractions or decimals, so it ends up being pretty. If you want to try it at home, you'll end up getting x equals -6. Okay, so now we've got to go deal with number 4 and number 6, and I'm not crossing out either of those because they have fractions. So what makes these a little more difficult is we've got to address the fraction.
Your first is 2 z's.
I could move all my z's to one side and all my numbers to the other side, and that's not a problem. But if you're looking at those steps at the top of your paper,
Eliminate the fraction.
the first step they suggest is get rid of the fractions. Let's kill off the fractions. So, well, so we could change it all to decimals. I'm not saying that we can't. And 0.5 and 0.25, that would be good, but the 1 over 3 is going to be 0.33333. So if we're going to have a rounding error, it's going to be with that. So that's the only reason why I'm going to hesitate and say, no, we're going to leave it with fractions. Is there some number we could multiply everybody by
2.
in order to get rid of all of those fractions?
2.
I'm needing a number that's got that 2, 4, and 3 divide into nicely.
9.
12. 2, 4, and 3 go nicely into 12. So why don't we multiply everybody by 12? If we multiply everybody by 12, I had actually quite a few, but you were one of the loudest. I'll give you that. I was impressed. 12 over 2z plus... He can have his silly point. 12 over 2z plus 12 over 4 equals 12 over 3z plus 60 over 4. And Miss Compton's being a bit ridiculous because really, did I have to write any of those fractions down? No, I can do some math in my head. What should I have written instead?
Can't you simplify?
Please do. Go ahead and start doing it, Paige. You were on it. You said 6z, and then what? Twelve over 4 is 3, so 6z plus 3, and then
4.
4z, and then 60 over 4 is 15. Okay, so I'm going to give table 3 tried hard. Table 3 their point for that. Do you actually have to write this step right here? No. If you're able to do math in your head and you knew 12 over 2 was 6 to begin with, you don't have to write this. If I subtract 4z from both sides, thank you for getting me back on track. That is not a point. You already got a pity point out of me. You'll have 2z plus 3 equals 15. So what do you end up getting finally? Someone already have that? I know what to do next, and I'm going to keep going, but can someone tell me the final answer? Who said it? Okay, you can have your point. Okay, so 2z equals 12, so z ends up equaling 6. Perfect. Perfect, perfect. Are there any questions on 5? Are there any questions on 5? Okay, 6. Oh, 4. Thank you. Whatever. Are there any questions from that one? No? Good. Okay, we get to 6. And again, we've got a fraction. And not like Natalie read, the first step is supposed to be to eliminate any fractions. So what number can we multiply everybody by to get rid of that fraction? The fraction's got to go. If we multiply, you can have your point. If we multiply everybody by 4, I would have, and I'm going to put do not need, because you don't need this line. Surely you can do this in your head, but I'm putting it for those of us who aren't following. I would have 4 times x plus 3 divided by 4 equals 5 times 4 is 20. But let's be honest, I consider this in my head, and I'm like, oh yeah, the 2 4s are going to cancel out. I already knew in my head the 2 4s are going to cancel out, so I don't even write that blue step. I go straight to x plus 3 equals 20. I subtract 3 from both sides, and I end up getting x equals 17. Okay. Now, you know how when you were in geometry and algebra 1, your teacher wanted to see every single step you had ever done? I don't have to see every single step you've ever done. I know when I see x plus 3 equals 20 and then you write x equals 17, I understand that you subtracted 3 from both sides. I do understand that. So easy math like this step, you don't have to show me anymore. Unless you like to, because you're like me, you're a creature of habit. But you don't have to. I'm smart enough and you're smart enough now that I know subtracting 3 from both sides, 20 minus 3 is 17. I don't actually have to write it. Okay, are there any questions about solving these equations? Then flip it over to the next page. We've got some more equations to solve. We're going to skip number 7, and we're going to go to number 8. I want you to go ahead and distribute that 4 while I get out my other piece of paper. Go ahead and distribute that 4.
Can I get a calculator?
Absolutely.
Are they all large?
No, some aren't. Look at the draw. I go higher, yeah. I've got it by batteries. Okay, so you distributed the 4.
Okay.
And you got -8, and table 3 can have a point. And then I'm looking to see if there are any like terms that I can combine before I start moving across that equation. Arturo.
R and negative 4R.
R and negative 4R. So I have 7 minus 3R equals R minus 4R is a negative 3R. So negative 3R minus 8. I combined R and negative 4 and got negative 3. That's all I did between the green and the blue. Which is kind of what we've been practicing in Math Workshop anyway, combining like terms. Okay, and then we run into this real big disaster, because you would say, Miss Compton, why don't you add 3R to both sides? And, oh no, my R's have completely canceled out.
Uh-oh.
So you automatically are like, oh, what should I put? So I actually have 7 equals negative 8. So what is my answer?
That's your answer.
Is that possible?
No.
Does 7 actually equal negative 8?
No.
So what should I put?
A lot.
Well, we know that's not true, but what am I going to write in words?
No solution.
No solution. So in your head, you're thinking, okay, so if the variables always cancel out, then it's a no solution, and that's not necessarily true. You actually have to pay attention like we did and see what the statement ends up making at the end. We had 7 equals negative 8. We know that's completely not true. But on this next one, we're actually going to find out a true statement, and it's going to end up being infinitely many solutions or all real numbers. Okay, is everyone good on number 8? Then let's go to number 9. Go ahead and distribute that 5. So you have 5h minus 10 plus 3. And I'm going to go ahead, she's ahead of the game. I'm going to combine those like terms on the right. And I have 5h minus 7 equals 5h minus 7. Hey, I have the exact same thing on both sides, don't I? So if I want to cancel out the 5h's, I can. But I kind of been smart enough from there that if they look exactly alike at that line, I know it's going to be everybody, all real solutions. But if you like canceling things out, you can. So I end up having negative 7 equals negative 7. So I'm going to put the R that we talked about the other day. And it stands for all real numbers. Just a reminder. Meaning as long as we don't plug anything crazy in like pi, if we plug in a normal number, it should work out. Yes, ma'am.
I did it in different ways.
You're allowed.
But like, I did it like that, and it still
That's
canceled
fine.
out like
Yes,
that.
that's fine.
Is that still like
Yeah.
good?
That's still good. Okay, Natalie did it differently. What she did is she immediately saw the 5 H's were going to cancel out. So she did that first before combining like terms. Can't be mad at that. Cannot be mad at that. Okay, so yay, those seem pretty fun. You're like, I'm pretty good at math today. I got this. And then, of course, you look at 1, 2, and 3 further down, and it's all letters. If you took me, Bill, if you took me in pre-AP Algebra 1, we spent a lot of time on this. We called it literal equations, and it was just solving an equation for a specific variable. So I'm not going to do number 1. But on number 1, all we want to do is get h by itself, so we would just divide both sides. So if you want to know the answer, which is really doing all the work, it's z divided by p q to the third equals h. Okay, so we get to number 2, and it says that they want us to solve this equation for a. They want us to solve this equation for a. So I could, if I want to solve for a, well, that means I need to get a on a side all by itself, right? So I need to move the bx and the c over. So I'm going to subtract bx and c from both sides. So I will actually have minus c, and if I do it over here too, you can't really see it. I'll have y minus bx minus c equals ax squared. All I did was move the bx and the c to the side with the y. But since I did it, changed their signs. Okay, so, and if you need to see it, are you cool? Is there anyone not cool? Okay, so it was, and if I left a little more space, it'd be easier. So it was y equals ax squared plus bx plus c. I've got to move over the b, and I've got to move over the c, because they're bothering that a. And when I move them over and cross that equal sign, I end up getting y minus bx minus c equals ax squared. The b and the c are what's bothering the a, right? When you move them to the other side, doesn't it change their signs? Yes. When you subtract it, when you move something from this side and move it to the other side, it changes its sign. So since we're moving the b over, it becomes a negative bx. Since we're moving the c over, it becomes a negative c. Okay. Now, could you have done it in 2 different steps and just move the bx over and then just move the c over? Yes, but we're pretty smart today. Is a by itself? Have we solved for a?
No.
What's bothering a?
X.
Okay, how do we get x squared? How do we get rid of it?
Cancel it out.
We're going to have to divide. You can have a point. So we're going to have to divide both sides by x squared.
I can have a point.
No, table 3. Sorry, babe.
I said cancel it out.
I don't believe you. So I end up having y minus bx minus c all divided by x squared, and that equals a. And I really don't blame you if you don't write it again and you just cross off the x squareds and say Miss Thompson, you know what it is from here. Okay, so that was pretty tricky. You might have to go back and watch that one again.
I didn't understand how to do that.
You do.
There's just so many letters I can't like my eyes.
You really do. Okay, so you see number 3, and they say we need to solve for a. but I probably need to, I have to get A by itself.
Distribute.
So let's distribute. So we could do that first, and we would have C times A plus C times B minus D equals F. Now, there's nothing wrong with that. We can do that.
What did you combine CA and CB?
Can we? They're not like terms. If it was CA and CA, or 2CA, we could. Okay, what letter are we solving for again?
A.
So we've got to move anybody who's not an A has to go. So we've got to move over CB, and we've got to move over D. Those cancel out, those cancel out. I end up having CA equals, and then F minus CB plus D. Yes. So my last step is A's still not by itself. C's bothering it, so I've got to get rid of it. So I divide everybody by C. So she is correct. My final answer is F minus CB plus D, all divided by C. Now Natalie is correct. Not Natalie. Yes, Natalie is correct, and that there are a lot of letters going on. I'm not going to be mad at Will if he puts BC instead of CB. I'm surprised I put CB, knowing me and my alphabet. You know how I like to fix things. Or if Will wants to put it in alphabetical order in the numerator and he wants D minus CB plus F, I can't get mad at him as long as he has A by itself, everyone else on the other side, and he's not messed up any rules of math. English I can forgive him for. But as long as he's not killed any rules of math, I can't be mad at him if his answer looks a little different than mine. Meaning that his numerator might be in a different order. Okay, and then if you were really fancy, and I mean super fancy, and you do not have to be this fancy, but if you were super fancy, you would say, hey, the real answer is F plus D over C, and then minus B. How do you get to be that fancy? You realize, hey, there's a C in that middle term, and there's a C in the denominator. I bet if I took F and B and put them together, and I took CB and put it over C by itself, it would end up being just B. You do not have to be this fancy. It's just for those of us who enjoy being fancy. Okay. Now I know that was heartbreaking for you. Flip to the back. We finally get to some problems that have both letters and numbers, but we're still solving for a specific letter. So on 4, it says we got to solve for y. So what's the first thing we should do to solve for y? Got to move the x over. How do I move the x? Set if you can have a point.
Subtract the A.
So let's subtract x from both sides, and we would have 2/5 y equals z minus x. That looks great. What's bothering y?
2 over 5.
Okay, how do I get rid of the 2/5? I could, but what do we normally do with fractions? This would get you, oh, Ms. Brister stole all your points. You multiply by the reciprocal. You multiply by the reciprocal. So I can multiply both sides by 5 over 2. If you multiply both sides by 5 over 2, on the left, the 2's and the 5's cancel out, so you end up with just y. And on the right, you have the 5 halves and the z minus x. If you want to distribute, you can, but you don't have to because we've reached our goal. Y is all by itself, so we're happy. Yes, ma'am.
Okay, can we put it in dumb version for me? So basically, you're just taking everything and moving it over to where the equal sign is on this dot.
Yes, you're moving everybody over away from the letter that you want. So on this next one, since we want y, we're going to have to move the 2 over. We're going to have to move the x over because y's got to be by itself.
Thank you. Like, you just got to put it in dumb version for me, you know?
You really got this. You're just mad there aren't numbers. You're better at numbers, I know. Okay, so number 5, we got to solve for y. I got to get rid of that 2. How do I get rid of the 2?
Multiply by 2.
Okay, let's multiply both sides by 2. I have not heard a lot from table 6, just saying. So when I multiply by 2, the numerator and the denominator cancel out. So I end up having x plus y
Equals the
equals 2b.
2b.
Because we multiply by 2 on both sides. Okay, and we're solving for,
Y, so
So-
put the x over to the other side.
so I need to subtract x on both sides. And my final answer is y equals 2b minus x.
Okay, so this is what, like, you're not actually solving.
I'm not really doing anything. I'm just moving junk over. Is the
Okay.
2 still there in some form? Yeah. Is an x still there? Yeah. We're just solving the equation for a different letter. I swear it'll be useful. It's like we do all these like semi-useful things and then make them useful. I don't know. It's weird. It's weird, weird, weird. Okay, and you're like, Miss Compton, can we please lay off that? Yes, we can. We're going to move on to absolute value equations. I know there is there's a 15 question quiz tomorrow. I know one of the 15 questions is an absolute value question. I know one of the 15 is an absolute value question.
Do we mark 4 out?
We are not doing number 4.
Thank you.
And we probably won't do number 3 either.
Doesn't those lines need to divide?
No, those lines were the absolute value bars, remember? They make everybody positive.
Oh, yeah, fine.
Okay, so with an absolute value equation, how many answers are you supposed to get? You always get 2 answers. You should always have 2 answers. So if you make a note to yourselves, abs val has 2 answers. 2. You're supposed to be getting 2 answers. Unless, of course, we have a double answer and no solution, but with a regular one like number 1, you get 2 different answers. 2 of them. Okay, and for that, we cross out 3 and 4. For those of us who want to know, the reason we cross them out is because Ms. Compton's not in the mood to deal with all the fractions. So, one answer for number 3 is negative 1/4. The other answer for number 3 is negative 9/28. Aren't you happy I skipped that?
Yeah.
One answer for number 4 is negative 3. However, the other answer for number 4 is negative 23/3. So if you need more practice, I recommend you try these later. However, Ms. Compton's going to let them go. Okay, so you were supposed to learn this with your algebra teacher. When we do the absolute value bars, it makes everybody positive, right?
Yes.
So we don't know. What we're really wanting to know is we're not sure if D plus 5, I get that 4 plus 5 is 9. It's not, it's absolute value. 9 is 9. I get that. You don't have to write this purple, by the way. I'm just telling you what we're about to do. I get that. But we don't know that it wasn't 13. We don't know that it wasn't negative 14 plus 5. Because negative 14 plus 5 is negative 9. And then with those bars, it ends up being positive 9. So that's why we have to consider both situations. Because the bars make everybody positive. So we're not sure if the inside really was positive or was the inside really negative and then the bars made it positive. So that's why we end up having 2 answer choices. Okay, so what we're actually going to do is we're going to pretend we're going to do D plus 5 equal to 9.
You said D plus 5?
Yeah, it's a plus 5. It's ugly, but it's plus 5. And we're also going to do D plus 5 equal to negative 9. Because again, inside those bars, we're not sure if it was really positive or negative because the bars made it positive anyway. So we've got to consider both options. Inside, was it really positive or inside, was it really negative?
I don't think it's
Okay, so you subtract 5 from both sides. You end up getting D equals what? 4. 6, was that you? You can have a point. Oh, Addison's table's about to lose a point if she don't lay off. And then,
negative 14.
yes, if you subtract 5 from both sides, you get D equals negative 14. Are there any questions about that?
Is that the answer?
That is the answer. Those are our 2 answer choices. That was the one problem.
I see the 3 outside of the bars next, so I'm kind of scared.
Okay, so you think, hey, I really want the bars to be all by themselves, so maybe we should divide by 3 first, right? So we have absolute value 2a minus 4 equal to 0. Well, I just told you that normal problems have 2 answers, but this is not a normal problem. because 0 is not a normal number. Is there a positive 0 and a negative 0?
No.
No. So I'm not going to do 2a minus 4. I'm going to do 2a minus 4 equals to 0, but I'm not silly enough to think I'm going to do 2a minus 4 equals to negative 0. I learned better than that. That's not possible. I'm going to scratch that out. I shouldn't be thinking like that. So what do you end up getting? A equals what number? Table 3, you can have a point. But again, Seth wants 100. So in all these problems that we're practicing, except for the last couple where it was all variables, but all the problems that we're practicing with actual numbers, he could plug back into 2 and make sure everything works out. 2 times 2 is 4. 4 minus 4 is 0. He really is right. Okay, and then our last one of the absolute values on this side is number 5. I like to get the absolute value all by itself.
Divide by 2.
I need to divide by 2, but what should I do before I divide by 2?
Minus 8.
Let's subtract 8 from both sides. It's just like when you were solving an equation. You have to get everything away. We were getting everything away from a certain variable. Now we're getting everything away from those absolute value bars.
Negative 2.
So we have 2 absolute value 3x minus 4 equals negative 2. If I divide both sides by 2,
You can't go to 0.
I have absolute value 3x minus 4 equals negative 1. And then we're at a problem.
There's a negative in absolute value.
Is there any way that when we absolute value whatever's inside, like if I plug in a 2 or a 3 or whatever, is there any way that what's inside is going to end up equaling that negative 1? No, because the bars make everybody positive. So there's no way that this can equal negative 1. So what should I write? No solution.
I thought it was supposed to be positive.
What do you mean? The negative 2 divided by 2 would be negative 1.
No, the negative 4. Minus 4.
It is, I mean, if I plug in 3, for instance, it'll be 9 minus 4, which is 5. But even if you plug in 3 and make it negative, if you make it negative 16, when you do the bars, it's going to make it positive 16.
You just want to make it positive, like for your eyes, like
No.
in your head, you know it's positive, but you wouldn't make it positive on paper.
In your head, I know that this inside, whatever I plug in, is going to be positive, yes. But on the paper, no, yes, I agree with you. Okay, I hear you all packing, and you're breaking my heart, but that is okay. You're supposed to do 1 through 15 odd on the back, on the top.
We're only do done.
But you only have to do the odd. So 1, 3, 5, 7, 9, 11, 13, 15. I'm going to pretend that everybody did that other homework and give everybody some points for it. I can pretend that for today.
Don't break your heart.
I can pretend that for today. Tomorrow we're taking a quiz, but we were supposed to do a checkpoint today. Run like a wind, Gracie. We were supposed to do a checkpoint today, so we'll try to do the checkpoint first. So it could be that Addison has to come to 0 period to finish her quiz because she could never pass the checkpoint. And that way at least I know you passed the checkpoint before I give you the quiz that's worth more. You know what I mean? I think that sounds like a good idea. In fact, if you wanted to do the checkpoint for homework, I'm willing to give it out. Just come see me now.